Okay, in this video I want to talk about how do we actually go about solving for f inverse. So if I give you a function f of x, how do we find the inverse function for it? And I'm going to look at a particular example. I'm going to look at f of x is equal to x cubed plus 6. Okay, so we have a set of rules on the far left that say what we're supposed to do. We're supposed to write it as y equals a formula. And so we're not going to use f of x, we're just going to use x's and y's as our inputs and outputs. And then we're going to swap the x's and y's for some reason and solve for the new y. I'll explain why this works in a minute, but let's just try it for this example. So instead of writing f of x equals formula, I'm going to write y equals formula. Okay, nothing really happening so far. And then I'm supposed to swap x's and y's. So here's an x, there's a y, swap them. Okay. And then I'm supposed to solve for this new y. So I'm going to try and solve for y. Okay, so I don't want to take a cube root just yet, because then I would mess up this 6 and confuse myself. I think I want to subtract 6 from both sides first. So let me subtract 6. And we'll get x minus 6 is equal to y cubed. And now I'm in pretty good shape. I can get rid of the cube by using a cube root on both sides. So let's use a cube root on both sides. And I end up with y is equal to cube root of x minus 6. Okay, so that's the end of the instructions. So I guess this is my inverse function. The original was f of x, so this would be the inverse, so f inverse of x. And our formula is the cube root of x minus 6. Okay, so could we have guessed this? Maybe. But honestly, if I had guessed, I might have guessed wrong, because the function is cube the x and then add 6. I would assume, if I was guessing, that our inverse function would be take a cube root and subtract 6, not subtract 6 and then take a cube root. That's kind of weird, but apparently that's the function that's going to make it work. Again, we need to make sure that f composed with f inverse works out to be back to the x that I started with. Okay, let's talk for a second about why this is supposed to work. The idea of an inverse function is that the output of one function is the input of f inverse. So back to my little silly drawing. If b is the output of f, b is also the input of f inverse. So what f sees as his x, f inverse sees as his y. So the x for f is going to be the y for f inverse and vice versa. Important thing that that's going to mean is actually that the domain of f is the same as the range of f inverse and vice versa. It's kind of irrelevant for the problem on the board because they both have domain and range minus infinity to infinity, but still. Later on it will be relevant to us that the domain of one function is the range of its inverse. And again, I'm not really being super detailed about why this is true. I'm just saying kind of the gist is that if this is the output of f, this should also be the input of f inverse. If this is the input of f, this should be the output of f inverse. And so kind of when I'm swapping the x's and the y's, right in this step where I swapped them, this is where we switched from suddenly these are formulas or equations that spit out the function f, the relationship between x and y is this function, to suddenly these equations all represent a different relationship between x and y, and specifically it's going to be the inverse relation. Okay, that was a bunch of theory that maybe we didn't need to talk about, but the idea is as simple as these 3 steps. We basically want to swap our inputs and our outputs and solve for the new output, and that'll give us the inverse function. Okay, let's try another example. Change the function f of x. I will pick x plus 1 over x minus 4. Okay, so I'm supposed to write, instead of f of x, write y. So y equals formula. And then we're supposed to swap the x's and the y's. And then I'm supposed to solve for the new y, which is this one. And again, the top two equations represent the original function f. All the equations from now on are going to represent f inverse. Okay, so solving for y is sometimes very simple and sometimes very not simple. This is one of the latter case. We're going to have to be creative in how do we solve for y. Going all the way back to chapter 1, when I have equations with fractions, I think to myself, man, I hate equations with fractions. Our strategy to get rid of equations with fractions is multiply both sides by the denominator or the common denominator. So I'm going to start off this problem, solving for y, by multiplying both sides by y minus 4. If I do that, then the y minus 4 on the right will cancel. I'm going to go ahead and distribute the left-hand side, x times y, and 4 times x. Okay, this still looks like a bit of a headache because when we were solving equations in chapter 1, we were solving for one variable and everything else was pretty much a constant. Now we got variables kind of all over the place, x's and y's. But again, keep in mind what we're trying to do. We're trying to find y, and it's not going to be enough to subtract 1 from both sides because I can't have y depend on itself. I want to have all of the y's together. So I think that's probably going to be my next step. If I was solving an equation, I would try and combine like terms to put the y's on the same side. So I think I'm going to subtract y from both sides, and I'll move this 4x to the other side. So I'll add 4x to both sides, and I'll subtract y on both sides. These still aren't quite like terms, so I'm just going to have to leave the left side as xy minus y. My 4x's will go away, my y's will go away, and I'll have 1 plus 4x, or 4x plus 1. Okay, I'm making progress. I just need to figure out how to get y by itself, and so I'm going to factor out y. So x minus 1 multiplied by y. And then, I guess, if I divide both sides by the thing in parentheses, the x minus 1, then I should have y by itself. So y is going to be equal to 4x plus 1 divided by x minus 1. Okay, this is y, but it's also, again, our inverse function. So instead of y, I could write equals f inverse of x. Okay, so again, we have to be a little creative sometimes in how we solve for y, but it is just swap the x's and the y's and then solve for whatever the y is.